First, what is quadratic equation? Quadratic equation is nothing but an equation in the form of ax square plus bx plus c is equal to 0. This form of equation is called quadratic equation in variable x. Why? Because you have used variable x. X is the variable and a, b and c are real numbers. They are constants and a should not be equal to 0. Let me repeat once again. Quadratic equation in the variable x is nothing but equation of the form ax square plus bx plus c is equal to 0, where a, b, c are real number and a should not be equal to 0. Because if a is equal to 0, this component is gone, right? Then the equation will be of form bx plus c. But the highest power, if you see of, in that case, see, if a is 0, then the equation will be bx plus c. And in this the highest power is 1. So it is no longer quadratic equation. This is a linear equation. Quadratic equation, as we have learned, that an equation where the highest power is 2. Here if you see, the highest power of x is 2. Thus quadratic equation of the variable x is nothing but equation of the form ax square plus bx plus c, where a, b, c are real numbers and a should not be equal to 0. Let me take some example. For example, 3x square plus 2x plus 5 is equal to 0. This is example of quadratic equation. Why? Because this is of the form ax square plus bx plus c, where a is equal to 3, b is equal to 2 and c is equal to 5, and where a is not equal to 0 obviously. If I say 2x square plus 5 or 2x square plus 3 is equal to 0, this is also quadratic equation because this is a is 2, b is 0 and c is 3. But if I make a is equal to 0, for example, if I say 2x plus 3 is equal to 0, because here a is 0, then this is not a quadratic equation because the rule says that a should not be equal to 0. If both b and c are 0, that is also okay. For example, if I say x square is equal to 4, this is also, or x square is equal to 0, this is also a quadratic equation. Why? Because here a component is not 0, a is 1. Correct? So quadratic equation is nothing but a form of equation of the form ax square plus bx plus c is equal to 0, where a should not be equal to 0 and all a, b and c are real numbers. They are constant.
Roots of the following quadratic equations. Note that we've been asked only for the nature of the roots and not values of the roots. The first thing we need to know is that for the quadratic equation ax squared plus bx plus c equals 0, the roots are given by this formula. And the nature of the roots depends on this value, which is called the discriminant. If it's greater than 0, then the quadratic equation will have two distinct real roots. If it's equal to 0, then the quadratic equation will have equal real roots. And if it's less than 0, then the quadratic equation will have no real roots. Keep this idea in mind. Let me solve the first one for you. The first thing we need to do is find the values of a, b and c. Comparing the first equation with the general form, we get the value of a as 9, b as -12 and c as 4. Now it's easy to calculate the value of b squared minus 4ac. It will equal -12 squared minus 4 times 9 times 4. -12 squared is 144 and 4 times 9 times 4 is also 144. So we get the value of the discriminant as 0. What does this tell us? It tells us that this quadratic equation has two equal and real roots. Try solving for the roots and verify your answer. Now I want you to try finding the nature of the roots of the second question. Comparing the second equation with the general form, we get the value of a as 2, b as -9 and c as 4. What will be the value of b squared minus 4ac then? It will equal 49, which is positive. This quadratic equation will have two distinct real roots as its discriminant is positive. And you should be able to solve the third one easily. we get the value of the discriminant as -7. This quadratic equation will have no real roots. You should try solving the above equations to verify your answer, and it's a good chance for practice too.
In question 1 of this exercise, we have to check whether each of these given equations are quadratic equations or not. So we are given 8 equations, and in each part we have to check whether the given equation is a quadratic equation or not. So a quadratic equation is any equation of the form ax square plus bx plus c equal to 0. So in a quadratic equation, you must have a quadratic term, a term in which the power of the variable is 2. And if this term is missing, then the equation is not a quadratic equation. So let's start with checking the first part. So in the first part, the equation is x plus 1 whole square equal to 2 times x minus 3. So we'll try and write this equation in the form ax square plus bx plus c equal to 0. So let's expand the left hand side. So if we expand the left side x plus 1 whole square, we will get x square plus 2x plus 1, and on the right side we will get 2x minus 6. And now the 2x terms on both sides cancel out, and we have x square, we have 1, and this minus 6 I can bring to the left side, and this will give me x square plus 7 equal to 0. So this equation is a quadratic equation because it has an x square term. So in the first part, the equation is a quadratic equation. So let's write it here. Part 1, we have a quadratic equation. Now let's do part 2. So in part 2, the equation is x square minus 2x equal to minus 2 times 3 minus x. So we have this product on the right side. We will expand it, and then we will try and write the whole equation in this standard form. So we have x square minus 2x, and then on the right side we expand this product. We have minus 6 and plus 2x. And now let's bring the terms on the RHS on to the left hand side. So this 2x I bring here on the left hand side, and that becomes minus 2x. So we have x square minus 2x, so that's minus 4x, and this minus 6, when it comes to the left, it becomes plus 6. So x square minus 4x plus 6 equal to 0. So this is also a quadratic equation. So the equation in part 2 is also a quadratic equation. Now let's go to part 3. In part 3, the equation is x minus 2 times x plus 1 is equal to x minus 1 times x plus 3. Now let's expand the products on both sides of this equation. So on the left side we will get x into x, or x square, then x into 1, that's x, then minus 2 times x, that's minus 2x, and then minus 2 times 1, that's minus 2. And on the right side I will get x times x, that's x square, then x times 3, so that's 3x, then minus 1 times x is minus x, and then minus 1 times 3 is minus 3. So now we see that the x square terms on both sides cancel out, and we get x minus 2x, or minus x minus 2, is equal to 3x minus x, or 2x minus 3. So we don't need to go any further. We can clearly see that there is no quadratic term in this equation. So this equation is not a quadratic equation. So I'm just going to put a cross here, meaning that this equation is not a quadratic equation. Now let's do part 4. So in part 4, the equation is x minus 3 times 2x plus 1 is equal to x times x plus 5. Now let's expand the product on the RHS. We have x times 2x, so that's 2x square. Then we have x times 1, so that's x. Then we have minus 3 times 2x, that's minus 6x, and then we have minus 3 times 1, that's minus 3, and on the right side we have x square plus 5x. And now we see that we have 2x square and x square. So if I bring the terms on the RHS to the LHS, I am left with x square, and then I have x minus 6x, that's minus 5x, and then another minus 5x, so that's minus 10x, and then I have minus 3. So x square minus 10x minus 3 is equal to 0. So clearly this is a quadratic equation. So let's write Q in front of part 4, and the equation in part 4 is also a quadratic equation. Now let's do part 5. In part 5 the equation is 2x minus 1. 2x minus 1 times x minus 3 is equal to x plus 5 times x minus 1. So let's expand the products on both sides. So we have 2x times x, so that's 2x square. Then we have 2x times minus 3, that's minus 6x. Then we have minus 1 times x, that's minus x. And then we have minus 1 times minus 3, that's plus 3. So that's on the LHS, and now on the RHS we have x times x, so that's x square. X times minus 1, that's minus x. Then we have 5 times x, that's 5x. And then we have 5 times minus 1, so that's minus 5. So now if we rearrange the terms, we have 2x square here and x square on the right side. So I get x square on the left side, and then I have minus 6x minus x, that's minus 7x, and on the RHS I have minus x plus 5x, that's 4x. When I bring this 4x to the left side, I will get minus 11x, and then I have 3 and minus 5. So if I shift the minus 5 to the left side, I will get a total of 8 as the constant term. So this equation is x square minus 11x plus 8 equal to 0, which is once again a quadratic equation. Now let's do part 6. In question 2 of this exercise, the problem statement says, represent the following situations in the form of quadratic equations. So we have these 4 word problems, word situations, and we have to convert each one of them into a quadratic equation. So let's start with the first part. So in the first part, the statement says the area of a rectangular plot is 528 meters square. The length of the plot is 1 more than twice its breadth. We need to find the length and breadth of the plot. So just to help us think better, let's draw a quick visual. So suppose that this is the rectangular plot, and we have to assume one of the dimensions as a variable. So let's say that the breadth of the plot is x meters. So let's say that the breadth of the plot is x meters. This means that the length of the plot is 1 more than twice its breadth. So the length will be twice the breadth, so 2x, and 1 more than this, so 2x plus 1. So the length of the plot will be 2x plus 1 meters. And we are told that the area of the plot is 528 meters square. So from this situation, we can now easily construct a quadratic equation in x, and that quadratic equation will be 2x plus 1, the length, times x, the breadth. So 2x plus 1 times x is equal to 528, the area of the rectangular plot. And let's write it now in the standard form. So we have 2x square plus x equal to 528, or 2x square plus x minus 528 equal to 0. So this equation represents or models the situation in part 1. Now let's go to part 2. In part 2, the situation is that the product of two consecutive integers, positive integers, is 306. We need to find the integers. So the unknowns are two consecutive positive integers. So two integers that come one after the other. So let's say that the smaller of the integers is x. So let's say that the smaller integer is x, then the other integer will be the integer right after this integer. So the larger integer will be x plus 1, and we are told that the product of these two integers is 306, and from here we can make a quadratic equation in x. So the product of the two integers should be equal to 306. And now let's write this equation in standard quadratic form. We have x square plus x equal to 306, and this means that x square plus x minus 306 equal to 0. So this is the quadratic equation that represents or models the situation in part 2. Now let's do part 3. In part 3, the problem statement says Rohan's mother is 26 years older than him. The product of their ages in years 3 years from now will be 360. How we would like to find Rohan's present age. So just to help us think better, let's draw a visual. So let's say that this is Rohan, and let's say that this is Rohan's mom, and what we are told is that Rohan's mom is 26 years older than Rohan. So let's say that Rohan's age is x years. This means that his mother's age will be x plus 26 years. And what we are told is the product of their ages 3 years from now. So this is important. The product of their ages 3 years from now. So 3 years from now, Rohan's age will be x plus 3 years. And Rohan's mom's age will be x plus 26 plus 3 or x plus 29 years. So this will be their ages 3 years from now. And now the product of these ages will be 360. So we have x plus 3 times x plus 29 equal to 360. And from this we can write a quadratic equation in x in standard form. So let's expand this product on the left side. So we have x square plus 29x plus 3x plus 29 times 3, that's 87. So this is equal to 360, and this means that x square plus 29 plus 3, so that's 32x, and then we have 87 minus 360, that is equal to 273. So it's actually minus 273. Okay, so we have 87 minus 360 or minus 273. This is equal to 0. So this quadratic equation is the one which models the situation given in part 3. And now let's do part 4. In part 4, the statement says a train travels a distance of 480 kilometers at a uniform speed. If the speed had been 8 kilometers per hour less, then it would have taken 3 hours more to cover the same distance. We need to find the speed of the train. So let's make a quadratic equation in the variable v, which is the speed of the train. So let's say that the speed of the train is v kilometers per hour, and we will form a quadratic equation in v. So the train travels a distance of 480 kilometers at uniform speed at the speed of v. So to cover a distance of 480 kilometer, the normal time would be 480 the distance by v, which is the speed. So 480 by v hours. Now the statement says if the speed had been 8 kilometers per hour less, so if the speed of the train was, instead of v, if it was v minus 8, then it would have taken 3 hours more to cover the same distance. So it would have taken 3 hours more than this normal number of hours. So that is 480 by v plus 3. So this is the normal time, and you add 3 hours to it, and this is the time it will take the train to cover a distance of 480 kilometers if its speed is 8 kilometers per hour lower than usual. But the total distance traveled by the train which is the product of this speed into this time, this will still be equal to 480. So from this equation we can form a quadratic equation in V. So let's do that. So we have V minus 8, and then we have here we have 480 by V plus 3. So let's take the LCM. So we get 480 plus 3V, and let's cross multiply this V on the right side. So this becomes 480V. Now just to simplify things a little bit, we see that there is this common factor of 3 that can be taken out from both of these terms. So let's do that. So V minus 8, and if I take out a common factor of 3 from the second bracket, I have 160 plus V, and the common factor of 3 I divide it on the right side, and that gives me 160V. Now let's simplify by expanding the LHS. So we have V times 160, so 160V, plus V times V, that's V square. Then we have minus 8 times 160, that's minus 1280. And then we have minus 8 times V, so that's minus 8V. This is equal to 160V. So the 160V terms cancel out, and we are left with V square minus 8V minus 1280 is equal to 0. So this is the quadratic equation that models the situation given in part 4. And with that, we've covered all the 4 parts of this question.
Thank you for watching our channel. If video உங்களுக்கு பிடிச்சிருந்ததுன்னா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம